Let's look at a few more examples. In this one, we have a fraction that we need to get rid of. But the rules still apply, that I'm going to use my distributive property to get rid of the parentheses. So I'll have 3/4 c plus 3/4 minus 5/6, and it's still equal to 1/4. Now I don't need to move my variables to one side because they're already all on the left. I can combine these two like terms though. So my lowest common denominator is going to be 12, making my equivalent fractions 9/12 and 10/12. When I go to subtract 10 from 9, I'm going to still have a negative 1/12. Equaling 1/4, and the 3/4 c is still out here in front. Now I'm going to get rid of that minus 1/12 by adding a 12th to both sides of my equation, which means I need my common denominator again, which is still 12. So 3/12 plus 1/12 will give me a total of 4/12 on the left, and my 3/4 c on the right. Now I multiply by the reciprocal on both sides so that I can cancel out my pair of 3's and my pair of 4's and get c alone. Here I can do some reducing before I do my multiplying. So the 12 will become a 3 and this 4 a 1. 4 times 1 is 4, and 3 times 3 leaves me with 9. So we think that this answer is going to be c equals 4/9. In order to check it, I go back to my original equation again. So 3/4 times 4/9 plus 1, take away 5/6, should equal 1/4. Let's check and see if it does. My common denominator here to do the parentheses is a 9, so I'll change that 1 into 9/9, leaving me with 13/9 to multiply by 3/4. I can do a little reducing here before I multiply. A 1 and a 3 there. So now I have 13/12 to subtract 5/6. Common denominator of 12 will leave me with 13/12 minus 10/12, which is 3/12. And when I reduce 3/12, luckily, I got 1/4, so it all checked out. Our final example on this page finally sees a case where we have variable terms on both sides of our equal sign. So if you think back to that additive property of equality, you can move a term with its variable to the other side as long as you do the same thing to both sides. So if I subtract 3 v's, not just the 3, but the 3 and its v from the right side, and move it over to and do the same thing on the other side, I'm still keeping this equation equal. So that's going to leave me with 2v plus 15 plus 3v equaling a negative 10. Combining the 2v and the 3v, I'll get 5v plus 15 equals negative 10. Subtracting 15 from both sides will give me 5v equals negative 25, and dividing both sides by 5, v equals negative 5. Once again, I want to always check to make sure that I've solved this correctly. So I'm going to put that negative 5 in place of my v, giving me 2 times negative 5 plus 15 plus 6 times negative 5. And I'm going to hope that that ends up equaling, running out of room here, 3 times negative 5 minus 10. So looking at the expression on the left, it will simplify to negative 10 plus 15 minus 30. Negative 10 plus 15 gives me 5 minus 30. 5 minus 30 gives me a negative 25. Simplifying this left side, 3 times negative 5 is a negative 15. Subtract 10 more from it, and I also get negative 25 on the right side. So my equation is true. The value that you can put in place of v to make this be equal is negative 5.